Yes friends, so we are doing question number 7. Now in the question number 7, okay, which we are continuing, we are given here we have the sum of two terms. These are two terms, so this is the sum of these number of terms here. What are the number of terms? 5 terms are there. This one term and these 5 terms. There are total 6 terms we will expect them. So we have to find out, to find here the sum of the above terms. What are these terms? So we have here 47C4 plus sign of summation r is equal to 1 to 5, okay, and 52 minus r c3. So if I express this, if I put here r is equal to 1 to 5, then this will be converted into 5 terms. This will be equal to, let me write them, 47C4 plus, what was this? Here I am going to use one of the formulae which I talked about, the 3 formulae I talked about, okay. Out of that, one formula here I will use. I'll just explain that, but before that let me write these 5 terms here. If I put r is equal to 1 to 5, 1 to 5, 1, 2, 3, 4, 5. So in place of this r, if I put here 1, it will be then 52 minus 1, 51. 51 C3, then 50 C3 plus 49 C3 plus 48 C3 plus 47 C3. These are the 5 ones, 1, 2, 3, 4, 5. Because we have substituted here r is equal to 1, 2, 3, 4 up to 5. This is 1 to 5, okay. There are total 6 terms. So what we see here, the first term and the last term, they have the value of n same, 47. So the formula that we write here, formula, since we know that nCr plus nCr minus 1 is equal to n plus 1 Cr. Out of these below values r and r minus 1, r is greater. The sum of these two, nCr plus nCr minus 1, will be n plus 1 Cr. Out of r and r minus 1, r is taken. The greater value is to be taken in the below value. Okay, so this is n plus 1 Cr. This is the result here. Similarly, the first term and the last term, we are having the value of n as 47. And here it is 4 and 3. So first let me assemble them, write them together. That will be 47C4, the first term plus last term, 47C3. Sum of these two terms we have to write. Then 51C3 plus 50C3 plus 49C3. This is 49C3. Now last value is 48C3, because we have taken this 47C3 here in this bracket. So sum of these two similar terms, so we can say the values of n are the same. It will be equal to how much? 47 plus 1, 47, n plus 1, so 47 plus 1, 48. C out of 4 and 3, it is 4. The greater value is taken here, as r and r minus 1, r is greater. Okay, so plus, now left value is, our values are 51C3 plus 50C3 plus 49C3 plus 48C3. Okay, now let me take them here. So we are having here 48, now writing the first term and the last term because they are similar terms, 48C4, 48C3. So value of n similar. They can be written together, 48C4 and 48C3. The last term and the first term in the bracket. Now then 51C3 plus 50C3 plus 49C3 only, because 48 we have taken in the bracket. What the value of this? Let me write that value here. So what do we get here? So finally we get this is 48 plus 1, 49, 49C4, then this is 51C3 plus 50C3 plus 49C3. Now the last term and the first term, they are like terms. We can write them in bracket 49C4 plus 49C3, and in bracket this is 51C3 plus 50C3 now left over. The sum of these two values, these two terms, is 50, but 49 plus 150, 50C4 plus 51C3 plus 50C3. The last term, the third term, the first term, similar, or they are like terms, we can say. So let me write here. The like terms, first and third term, they are 50C4 plus 50C3. Let's write them together. Plus 51C3, the last term. This will give us 50 plus 1, 51, 51C4 plus 51C3. Now this will give us 52C4. Why? 51 plus 1, 52. 52C4. This is the answer. Finally, answer is 52C4. Alright. This is the question here. Let us take now question number 8. Question number 8, what does it say? Let me first read it and then solve it. Question number 8 now. Okay, now question number 8. Let us take question number 8. What is given to us? First, we are given here. Okay, to prove with or without the use of formula. Let me use the formula. So what is given? Here we have nPr. We have to prove that nPr is equal to n minus 1 PR plus R into n minus 1 P R minus 1. Okay, we have to prove this, to find or to prove the above values, above formula or whatever result. Prove the above result. We have to prove this result here. This left hand side equal to right hand side. Now let me take the formula here. Solution. Now try to understand the solution. Let me take right hand side here. Here right hand side is equal to, let me write n minus 1 PR plus R into n minus 1 P R minus 1. Okay, but let me open these two formulae. So the first term, we know that nPr is factorial n upon factorial n minus R. The numerator we will have this value of factorial of this value n minus 1 factorial divided by n minus R minus 1 factorial. The denominator. Why? Because n minus 1 minus R, or we can write n minus R minus 1 factorial, plus this is R into n minus 1 factorial divided by, so this R was already there, divided by this minus this. So this will be n minus R minus 1 plus 1. Why? Factorial. Minus 1 plus 1 cancels out. Minus 1 plus 1, sorry. Minus 1 plus 1 cancels out. So only n minus R factorial. We could write n minus 1 minus R plus 1. Minus R plus 1. So this is minus R here. We are taking first minus R. Or let me write it in the same way. With that. First is n minus 1, then minus R plus 1. If I subtract R minus 1 with minus sign, or open r minus 1 with minus sign, minus r plus 1. Plus 1 minus 1 cancel out. This is factorial n minus r. Okay, so let me take n minus r. We can write it as n minus 1 factorial. Let me write again n minus r minus 1 factorial. Plus, what about this? This is r into n minus 1 factorial divided by the denominator we are having n minus r. It will be n minus r into n minus r minus 1 factorial. Why this is? Because this n minus r is greater than n minus r minus 1. N minus r into n minus r minus 1 factorial. So this n minus r minus 1 factorial is common. In the numerator we are having n minus 1 common, factorial n minus 1 common. Okay, so let us take common. In the numerator we are having n minus 1 factorial common. The denominator we are having n minus r minus 1 factorial common. Within bracket we are having 1 plus r upon n minus r. This n minus r is left. R in the numerator, this r in the numerator divided by n minus r. Okay, let us take just further. Okay, so we are given here n minus 1 factorial we have taken common divided by n minus r minus 1 factorial. In the denominator we are having here n minus r taking LCM and plus r divided by n minus r, which is the LCM here, is minus r plus r cancelled out, n upon n minus r. What we have here n into this n into n minus 1 factorial divided by n minus r into n minus r minus 1 factorial. What is this? N into n minus 1 factorial means n factorial divided by this is n minus r into n minus r minus 1, that means n minus r factorial, which is nothing but nPr. Why? Because nPr means factorial n divided by difference of the two in the denominator, factorial of n minus r in the denominator. This value is nPr, which is the left hand side here, and this is equal to left hand side. This is left hand side. Okay, then this with the help of formula we can prove this. So this is the question number 8. We have completed this question number 8. Okay, now let us take next question. Question number 9 now. What does question number 9 say? Let me first check it and then solve it. Question number 9. What is given to us? First let me write here. Given. What is given to us? Okay, so in this case, question number 9. Now it says, how many numbers of the 5 digits can be formed with the digits 0, 1, 2, 3, 4, 6 and 8. Okay, so let me write here. We have the digits. We have, how many digits are there? 6 digits. Yeah, 3, 4, 4, 7 digits, sorry. So we have here, okay, 7 digits. We have the 7 digits which are, 7 digits here, 9th question. 0. We have the 7 digits 0, 1, 2, 3, 4, 6 and 8. To find, what we have to find here? We have to find here how many numbers of 5 digits can be formed with the above digits. We have to find out that how many numbers of 5 digits. Try to understand this question. 5 digits. How many numbers of 5 digits can be formed with the above digits? With the above digits. With the above digits. Now try to understand this question. This is the question here. Now let me find the solution. Now first try to understand. We have to find out 5-digit number. So in how many days, how many ways those 5-digit numbers can be, how many numbers of 5 digits can be formed with the help of this number. Now you see here that units, tens, hundreds, thousands and 10,000. These are the 5 digits here. How? This is units, tens, hundreds, thousands and 10,000. 5 digits. 1, 2, 3, 4, 5. So in the unit digits can be 0, no problem. But this 10,000th digit cannot be 0. Here in the 5-digit number, in the 5-digit number, 5 digits number, okay, 0 cannot be placed at 10,000s. Let me write here at 10,000s. At 10,000th place. Got the point? 10,000 place means from the left hand side it is the first point, on the right hand side it is the 5th point. On the right hand side, units, tens, hundreds, thousands and 10,000. 10,000 is the 5th digit from the right hand side. 5th digit cannot be 0. So we can, otherwise if 0 is on the 5th digit, then it will be only 4-digit number. So out of these 7 digits, only 6 digits. Out of 6 digits, those 6 digits can be, one of them can be placed on the 5th place from the right hand side, and or you may say 10,000th place. 0 cannot be. So the first 10,000th place, hence the 10,000th place can be filled in how many ways? Can be filled in 6 1, because 7 total digits are there, 0 is eliminated. 1, 2, 3, 4, 5, 6. So 6 digits. So 6 digits out of 6 digits. Okay, the place is 1, so we can write here 6p1. 6p1. That is equal to 10,000th place can be filled in 6p1 way. Place is 1. 6 digits are available. So out of 6 digits, 1 place is to be filled up. In how many ways it can be? Factorial 6 upon factorial 5. 5 times not 6 base equal to 6 base. So this is 6 base. 10,000th place can be filled in 6 base. Now remaining, now again 6 digits are left over. So remaining 4 places, that means 1000th place, 100th place, 10th place, units place, these 4 places can be filled out of those 6 digits. How? Okay, the remaining 4 places, can be filled out of 6 digits. Which are those 6 digits? Now 0 can be included. So this 1 digit is left over out of these any, but 0 and 1 out of this, left out. The remaining 4 digits, sorry 5 digits, and this one 6 digits. If total 7 digits are there, one digit has been selected. So including 0, other 5 digits are also there. So there are total 6 digits are left over. Out of those 6 digits, those 4 places can be filled. So 1000th place can be filled in 6 pages. Now remaining 5 numbers are left. Next in 5 pages, other is 4 pages. The units or unit place can be filled in 3 pages. That is how the other places can be filled. So let me write here. What are those pages? So the remaining 4 places can be filled out of 6 digits in 6p. 4 places are 4 left, and numbers we are having 6, so 6p4 equal to factorial 6 upon factorial 6 minus 4 means factorial 2. It will be 6 into 5 into 4 into 3, only leftover values. Of course, in the numerator we are having factorial 6 divided by factorial 2. So 6 can be opened up to 6, 5, 4, 3. Factorial 2 left out because in the denominator we are having factorial 2. So into factorial 2 upon factorial 2 cancelled out only. These are the 4 places can be filled in this way, because out of 6 digits, the 4th place from the right hand side, you can see the 1000th place can be filled in 6 pages. Now remaining 5 digits are there. Next place can be filled in 5 pages. Remaining 4 digits that can be, or 4 numbers are left. So next is 10th place can be filled in 4 pages. Units place can be filled in 3 pages. This total number. Now let me, so this 6 into this. So further, finally we are left with, hence total base, hence the total, in how many ways we have to find out how many numbers of 5 digits. Hence the total number of 5 digits. Total number of 5 digits equal to 6 into 5 into 4 into 3. So 6, the 10,000th place in 6 ways. Other remaining is this number. 6 is 36 into 5 4 is 20, 23 is 60. So 60 into 36. Let me write it here. The final answer is, hence the number of 5 digit numbers, 5 digits numbers, and the number of 5 digit numbers is equal to 6 into this, so 0, 6 is the 36, 6 3 carry, 6 3 is 18, 3 21, 2 1 3 6 0. 6 is the 36, 6 3 carry, 6 3 is 18 and 3 21, 21 0. The total number of 5 digit numbers. So this is the answer here. Question number 9. Now let me talk about question number 10. Next question is question number 10. Okay, now question number 10th, or 10th question now, or question number 10. What did it say? 10th question is what? Or question number 10 is what? Let me check it. Question 10 says, how many numbers of 5 digits can be formed? Okay, with the digits. Now here 0 is not there. 5 digits are there. 1, 3, 5, 7 and 9. Okay, so that we have found out. We are given here. Here we have 5 digits. Here we have 5 digits. Which are those 5 digits? 1, that is 1, 3, 5, 7 and 9. So 5 digits, 1, 2, 3, 4, 5. The 5 digits we have. Find here then. We have to find out here. Okay, how many digits can be formed? Question number 10. How many numbers of 5 digits can be formed? We have to find out here. How many numbers? How many numbers of 5 digits? How many numbers of 5 digits can be formed? With the help of the above digits, with the above 5 digits, with the above, and they say no digit being repeated. That is also given. Okay, how many digits can be formed? How many numbers of 5 digits can be formed with the above digits? And no digit is being repeated. No digit being repeated. That is the point here. Okay, now solution. Now try to understand this question. How do we find out this question? Let me just show you. First, now it says that out of 5 digits, naturally the first place can be filled in 5 ways. Remaining, now because they are not repeated, right? They are not repeated. What is the number of base? 5 numbers and 5 places, so 5p5. So the number of 5 digit number of 5 digit numbers is equal to 5p5. 5 places we have to arrange them out of 5 numbers. 5 places are there. They can be filled in factorial 5 upon 5 minus 5 factorial is 0. 5 minus 5 factorial is 0 factorial, which is 1. Now 0 factorial is equal to 1. This is factorial 5 upon 1. Because factorial, since factorial 0 is equal to 1. In the denominator we are having 1, this is equal to factorial 5. Factorial 5 means 5 into 4 into 3 into 2 into 1. So let me find out that value finally. Total number is equal to 5 into 4 into 3 into 2 into 1. We can write no problem. 5 for the 20, 23 is 60, 62 is 120. 120 is the answer. Okay, now if the numbers are repeated, let me tell you, then what will be the number? The numbers are repeated or digits are repeated. We say repeated means every place can be filled in 5 ways. 5 into 5 into 5 into 5. 5 times, right? It is 5 ways for 5 if the numbers are repeated. If the digits are repeated, then total number of 5 digits equal to, or will be equal to 5 ways for 5. Why? Because every place can be filled in 5 ways, 5 ways, 5 ways, 5 into 5 into 5, 5 times. Okay, so 5 ways for 5. But if they are repeated, but here we are given that no digit is being repeated. That means the first place can be filled in 5 ways, then, or we say 10,000th place can be filled in 5 ways. 1000th